Okay, shall we start? Kia ora, welcome. It is a great pleasure to introduce Bruce MacDonald. Bruce started with a PhD from the University of Canterbury. And after that, he started his academic career in Canada, where he stayed at the University of Calgary for 10 years before returning to New Zealand. When he arrived back in New Zealand, he founded the first robotics laboratory of the University of Auckland. And today he is the director of the Center of Robotic Engineering, the Center of Automation and Robotic Engineering Science, CARES. Thank you so much, Bruce. And we look forward to hear about your research in robotics in New Zealand.
Thanks a lot, Minas, and thanks for giving me the opportunity to talk about our robotics here in New Zealand. I'm going to talk a little bit about our work in CARES and then talk a little bit about the larger kind of national scene, if you like, and what's been going on around that area. In our work, there's sort of two areas that are most of our work is in. One's in assistant robotics, for example, in healthcare, and the other's in horticulture robotics. So I'll talk about those. Plus, we did a recent project. After I talk about the industry and research in New Zealand, I'll talk a bit about a roadmap that we got together as a group. So CARES is all about making robots to help people. So our focus is on improving the world for individual people as time goes on. So we try to focus on that in all of the work that we do. And so that's why we like the name CARES, and we managed to find some words to go with it, which Minas already said. So we have a website. The kind of streams of work are this bit about robots as assistants for people in healthcare, but not surgery robots. It's more like companions and helping people manage their daily activities so they can live happily and independently alone and have a good life, I guess. And then there's a stream in agriculture, which we started because agriculture is the kind of primary industry in New Zealand. And then there's a few other projects I'll mention later that we have done. The focus is, I guess, apart from the hardware technology and the software technology behind robotics, the focus is on humans and robots working together. So we're really keen to understand how that will happen in the future. You don't see many robots you guys see robots in your daily life, but most people don't. And so how will humans and robots actually work together in the future in the long term is one of the questions we're interested in. So we try to do studies that are a bit longer. And we try to do our studies in the field. A lot of people talk about it, robots in the wild, and I always want to ask them, which planet were you doing your studies on, because there's nothing really wild about most robotics field work. It's just different from doing it in the lab, but we think a lot more relevant. And so there's a piece in our work about commercializing the technology or transferring the technology to people to actually use, to companies and people who want to use it. And there's a university organization called Uni Services, which is a separate company that helps us with that. And that's pretty much most of what the streams of work are. There's a bunch of people involved in it. You can't really see their names, but the point about this slide is that it's a very multidisciplinary team. So all branches of engineering involved in the work, and people from medical and health sciences. So this is a medical school at Auckland. So some of those people have been involved in our project, and we work together with them to design what our robot should do. People from science, so computer science people are involved, and from some other sciences, and also from the social sciences. Lots of people have been involved in putting this together, and this is just some of the names of the students and staff over probably the last 20 years. And this is an example. I'll talk a bit now about our robot assistance project. I just got to figure out how to start the video. Oh, here we go. So this is one of the more recent studies we did of robots, people who have respiratory problems.
This project is funded by the HRC as part of a partnership program in innovation. And This particular project is looking at whether the robots can reduce hospitalizations in patients with chronic obstructive pulmonary disease, which is a chronic lung condition. In this study, we are recruiting 60 patients. So they're recruited from hospital. So after they've been in hospital for a COPD exacerbation, we recruit them and then we randomize them. So half of them get a robot to take home with them and half of them get standard care. This project is across both the Faculty of Medical and Health Sciences as well as Middlemore Hospital, and also with Faculty of Engineering.
The technical challenge for us has been to put the software on the robot so that it does the functions it needs to do in interacting with people. And that's really taking some kind of medical therapy and translating it so that it runs in software on the robot.
Great, thank you for performing those tasks.
There's a lot of things that have to kind of align. It's not just one bit of software like a game or something that has to integrate with the rest of the environment. So that's quite a challenge to get it robust enough. So those are the main challenges. Another one was connecting devices to the robot. So to do that, we need to hook a device up to the robot and program to talk to that device. And that shouldn't be challenging, but in practice, actually, it turns out to be more challenging than expected because it's quite hard to get devices that are open to us connecting up to them. So we had to do quite a bit of work.
Personally, I'm amazed at how well the robot is actually getting along with our patients. The patient have taken very well to the robot. They see them as an extra companion at home. But in addition to being a companion, it actually helps them check their health status, and then it gives us the connection as a health professional to monitor them at home. So the patient absolutely loves it.
Please take 2 pulse.
When I actually got to use him and found out what he does, I was excited. Kind of changed my life.
Quite often, older people who live alone are at greater risk of exacerbations. So we hope that these robots will reduce some of that isolation.
He's very good company, and he does remind me of a lot of things, mainly my medication.
Let me know when you are ready to take up.
He's on the ball for me all the time.
One of the things that's different about this project is we really want to understand more deeply about how people and robots interact. So in this study, the robots are with people for 4 months in their homes all the time, 24/7. And that's a long time for a sort of a research study and for us to analyze and record data. And we're getting some information about what happens when people get used to the robot, have time to think about it and use it every day.
Thank you for taking your medications.
So we're hoping functions on the robot, such as reminding people to take medication and reminding them to do their exercises. This is going to prevent them from getting sicker. And also because the physiotherapist can monitor their symptoms over time, if she detects that there's something going wrong, she can intervene earlier before the patient gets so sick that they turn up at the emergency department and have to be admitted.
We cannot replace essential medical services. However, usually patient who comes out of hospital, they would have standard care by physiotherapy regardless. So that include going back as an outpatient, participation in community-based to what they're getting. And hope that we would like to use this as a channel to educate our patient, to continue the education that we started at the hospital in order for them to prevent readmission into the hospital.
So people with COPD have kind of respiratory attacks, maybe, and hospitalized maybe twice a year. And so we work here and help those people at home, basically therapy after they are discharged from hospital. They are randomized to get a robot or not. And then the robot helped them for a while. And what the robot does is just reminds them to take their medication, use their inhalers and so on. And we connected the inhalers up to the robot so we could track their in use, and the nurse can check on a dashboard on the website how that patient's doing, and then intervene with that patient if they think it's necessary. So we worked with, you saw the nurse in the video, we worked with her, and they made videos for the robot to encourage people to do exercises and to show them what to do, for example. And the study was run by Liz, who you saw in the video as well. She's a human robot interaction researcher and from the health psychology department at the medical faculty here. And we've done a lot of work together to do that. So what that study showed was that the results were people really liked the robots, and the robot interactions seemed to reduce the length of time they spent in hospital when they were next hospitalized. So we think it could reduce the burden on the healthcare system if robots had companions like that. We also found that the companionship relationship that people develop with robots was stronger than you might think. So that's something we're continuing to study. And that work, I'll talk about it later, but that work has kind of expanded into emotional interaction between people and robots. But before we did that study, we did a study with all of these robots, a number of studies at a retirement village here, not far away from where we were last night, just down on the coast from there at Selwyn Village. And they have a large retirement village. We had about 25 robots in the village in our final study, all these different kinds of robots on the video. So these 4 were from different Korean robot companies who we've worked with on these studies. Plus we had Paro in the village as well. But mainly these robots, and what our job was to reprogram these robots. This little one here was made for kindergarten teaching in South Korea, sold in China for kindergartens, for kindergarten children. And it had content on it for kindergarten education. So we reprogrammed it to sit on the bench for an older person and to interact with them, remind them to take their medication, remind them to do their exercises and so on. And these robots had sort of similar versions of the software on to do the same thing, but in larger rooms, larger settings. So this large one was kind of in public spaces in the retirement village, or in the doctor's in the doctor's clinic, where people were going to see the doctor in the waiting room, and people interacted with it, could interact with it on sort of a private or a public mode, if you like. Then that work has kind of expanded to, we did another study after that on a robot to help people with mild dementia. And that again was jointly with some Korean researchers at Iwa Women's University in the Brain Research Centre there. And Professor Kim there scans people's brains and showed after 4 months therapy with a robot like these that people's cortical thickness was improved as a result of the therapy. It's physical and cognitive therapy that the robot is doing, which is quite interesting. And then so we've moved on to kind of give the robot better dialogue and to understand speech better. And we're working on making the robot interact at an emotional level, so understanding people's emotions and also giving appropriate emotional responses. So, because I think the robot should show some empathy when it's interacting with people. So the current studies are trying to figure that out. And then that's also moved on. My colleague Ho Suk An, who has done a lot of work in these studies, now making a robot to translate sign language for Indigenous Maori people, so that Indigenous deaf Maori can have more interaction using sign language, because this is a bit of a gap at the moment. So he's got a couple of projects funded for that. And there's a few other projects. Andrew does stuff on the rehab and brain-computer interfaces. And of course, Minas has joined our university in the last few years and added this very strong stream on dexterous manipulation, which was something that we didn't really do before, but we should have been doing. And then we've got a couple of other projects on underwater robots and automation project in carpet at the moment. So those are the kinds we started doing. And then in recent years, we've moved on to work in farming. I always thought we should be working in farming because that's the key New Zealand industry, if you like. And so we started in 2014 with a project to make a multi-purpose orchard robot. And this project was by the New Zealand government. MB is one of the departments who fund kind of innovation and research. And so you have to propose projects and give them a business case to go with the project. So we did that along with Steve and Robotics Plus, who you heard from yesterday, who was a partner in this project. And the project was really driven by, all our horticulture work's been driven by a university-wide strategy about agri-tech and working with the New Zealand farming industry. Because historically, University of Auckland is not an agricultural university, and there are agricultural universities historically in the country. So Waikato, Massey, Lincoln have been dedicated originally to training the agricultural industry in New Zealand when those universities were first set up. They've broadened their scope now so that they kind of teach more or less everything. But we've never been focused on that. So the strategy was to partner with other people to do agri-tech, so to bring the technology from our university into the primary sector to improve productivity and the results from that, outcomes from that sector. So that the important point about this is it's all about relationships. So this strategy, agri-tech strategy, and the people at Uni Services developed the relationships which then led to these projects. So just emphasises the importance of the people relationships to get anything going. On the research side, we all pretty much knew each other well. There's kind of 4 partners in this first orchard project we did. And it was driven, 100% by the company requirements. So Robotics Plus guys. And Alistair had made a first prototype harvester in his PhD project. And then kind of that got held up, development of that got held up by some kiwi fruit disease problem in New Zealand for a few years. And then they came to us and said, we want to make better versions of this. So that was our mission, to make a platform to put the robot on. And which you'll see, Steve was talking about, they've commercialized a platform to do that now at the moment, doing spraying, but it has the opportunity to put all kinds of devices on the robot, depending what you want it to do. And our goal was to do precise spraying for pollinating kiwi fruit flowers, because kiwi fruit flowers are hard to pollinate. It's dark and cold in a kiwi fruit orchard because kiwi fruit grow in a pergola structure and bees don't really like it. So kiwi fruit growers will contract in beekeepers to bring bees to pollinate at the right time. So the idea was to spray pollen onto the flowers. This company already has a business in spraying pollen on kiwi fruit orchards, and the idea was to spray pollen everywhere, but it's quite expensive because he also collects the pollen, but it's like hundreds of dollars, thousands of dollars a kilogram to buy for the pollen. So by precisely spraying, you would reduce the cost. So that was our project, and also harvest the kiwi fruit and then do some harvesting of apples. So that was the idea, and the business idea is to export the technology to do that around the world, which is what Robotics Plus is doing now. So this video is going to show you about that robot doing the pollination and the harvesting. There are cameras up at the kiwi fruit, finding the kiwi fruit and telling those robot arms where to harvest them. And then they just go down a tube eventually into a bin. We used artificial lighting underneath to light up the canopy a bit because it's a bit dark. Although the vision problem is tricky because you're looking up through the canopy at the sky, sometimes at the sun, which makes it more difficult. The commercial trick here is you need to do it fast. Nearly every robot harvester that's been made in the last 50 years, and there's a lot of them, has been too slow to be economic. So it has to be fast enough, firstly, to be economic. Secondly, to harvest the kiwi fruit in the orchard, because you would probably want to go around and do all of the orchards in your region. You'll probably be contracting it as a service. This is the pollination now. So it's the same robot. but with a bank of nozzles on it, spraying pollen in solution at each flower. Technical problem here is there are cameras you can see on the find the flowers, track the flowers, and tell the sprayer exactly when to shoot a bit of pollen. It's like inkjet printing, pretty much. So you can see it's hitting some of the flowers. So by the end of the project, we were getting pretty successful at hitting the flowers. Evaluation's a bit tricky. What you have to do is you have to put a bag around each flower before it's pollinated, so at the beginning of the flowering season, and then take it off, put the robot underneath and pollinate the flowers. Then you put the bag on again, wait till the kiwi fruit grow out, and then evaluate the size, shape, and number of seeds in the kiwi fruit to see whether the pollination was successful. The better the pollination, the more seeds. So that's what we did, and it was reasonably successful. So then at the end of the project, we transferred all that technology to the company, and they're working on commercializing it. So that project finished a few years ago, and then we started another horticulture project, and this time talking to industry people about what they wanted in horticulture. Brought up, of course, the discussion was about labour, because labour's always been an issue, especially here in New Zealand. Often it's to get enough labour to harvest the fruit in the season. And the trick with this is that, for example, the flowering of kiwi fruit lasts about 3 weeks if you're lucky, if the weather's okay. If the weather's not good, it's shorter. And so you have to pollinate all the flowers of all the kiwi fruit in the region during that 3-week time. And if you're doing research, you have to get your software ready so you can do your evaluation. So if your software's got bugs in it and you can't get it working properly for that 3-week window, then you can't get any data, you can't do the evaluation that you need. And you need to do thousands of examples to get any sensible evaluation. I think and the same with harvesting. A couple of months, I guess, depending on which orchard you're in, and you change from orchard to orchard as the fruit was harvested. All the kiwi fruit are harvested. There's no selective harvesting. They're all harvested before they're ripe, because the business model here is the kiwi fruit ripen in the supply chain as the kiwi fruit get to the market. The idea that kiwi fruit arrive and for customers to buy. So we need to do selective harvesting. Window harvesting and pollination is quite short. So labour has to be available and do that. So this is why automation is a worthwhile task. But in talking to the industry in sort of 2017, before this project, it's a better. Yeah. Thank you. And talking to this project up. Is it all right? Yeah, okay. Quantity of labour. It's the quality of labour. So how job are people? And so yeah. Okay. I usually like walking around, which is why I got this, but maybe it's not really this plan. So the industry people told us we want to improve the quality of what people are doing in orchards and vineyards. For example, pruning wine grapes, it's really important that you prune the grape in the right way to get the right production of grapes and to manage the fruit loading on the vine. And the same for apples. You have to take applets off a tree, because normally with apples you have about like 5,000 flowers on any decent apple tree, but you're only really going to get 250 good apples. So you chemically make the plant drop a lot of the flowers, but then there's still too many. So people go along and manually remove the small apples when they start growing from the tree to leave one really nice apple in each sort of bunch that you grow out and put on the export market. And if you ask the growers, it's not worth kind of keeping a few more apples and choosing the best one and juicing the rest, because you just don't make any money doing that. It's only the really good looking apples that you can put in the export market that make you money if you're growing apples. So people need to do that, and it's expensive. So they wanted to help people do a better job and also automate the task with a robot. So there's a lot of database and machine learning stuff involved in that, saying software models, capturing images of the plant, making a 3D model of the plant, because all these decisions are based on geometry. So for grapevine pruning, it's all about the diameter of the cane, where the nodes are on the cane, and how you think that's therefore going to grow into a reasonable harvest of grapes for making wine. So that's how humans are trained to prune vines. And so we wanted to use the same rules for our robot to do it, and the same rules to show people where to prune the vine. So they'd be basically in our project, they'd be wearing a headset, which would tell them where to prune the vine, as well as having a robot to do it. The other thing we did was there's a social science stream in this project where people are studying how this technology will be adapted and used by communities, in particular how it will affect Maori and Indigenous communities. So there's a bunch of people interviewing the workers in orchards and vineyards, and interviewing the researchers, and understanding how this technology can be diffused into those communities, because it turns out that's probably the most important thing. So this is a diagram showing headset, people being told where to pick or where to do operations on the plants, and then the robot automating it. And then the way we did this was very much a co-design project with growers, including Maori growers, and the organisations, that kind of industry organisations and the technology manufacturers. So we all got together and designed this project, and then we get together regularly. We invite the industry people to come and see what's happening in the field when we're doing any studies. The guys were in the field a couple of weeks ago doing some apple work, and earlier in the year pruning grapevines. And then we have there are 6 research organisations involved in this project. So that's a mission to get everybody to keep on the same track and to do the same, to work together. So we have a group that makes that happen. And then there's an industry advisory group who we meet with regularly to get feedback about the project. And they tell us things like, yeah, well, we like your augmented reality system, but actually we'd like to use it for training. So we made a virtual reality, effectively a game. If you did our lab tour the other day, you would have seen the video for that, to train people how to prune grapes, for example. And that is being commercialized by a software company at the moment. The industry is kind of desperate for it. The other study we're doing is harvesting blueberries, because that's a trick. Half the cost of growing blueberries is the labor for harvesting them, and it's hard. We can harvest individual blueberries, but that's too fast, too slow. So we're working on ways to speed it up. And yeah, the idea is it will be commercialized. The project's still going on, so it finishes in 2024. So we're looking at blueberries have to be harvested selectively, so maybe 4 times a week. So we're looking at doing that, and colour is not enough, it turns out. So some of our colleagues at the government research lab are looking in plant and food research, are looking how to find a better way to decide when and where to harvest. The biggest problem is that people leave ripe blueberries on the bush, and then that just kind of degrades the quality of the blueberries that after when they're next picked. So we need to sort that out, and then we're still working on ways to get the blueberries off. This is going to show a bit about the vine pruning. So this is the robot that the guys at Waikato, Hin and Mike Duke and his colleagues, the robot was just out over here yesterday. They took it home last night. And so this just shows the robot doing a bit of work. We call it the Maratech project because Mara is the Maori word for garden. So there are cameras on each side of the the vine and then taking images and then registering those together and putting it together into a 3D model so we can extract those the geometry metrics that the growers use. It turns out every vineyard has their own rules for pruning, but they're all based on the geometry of the plant. So the idea was we would be able to extract that geometry and then apply, when you're going to a particular vineyard, we would apply their rules to the pruning, and the robot or the headset would make sure that it was pruned according to their rules. So this is just scanning. These are cameras on the robot arm scanning the vine. It's going to need to be faster in the long term. But at this stage of the project, we're just getting it to work. And so the idea is to generate a 3D model and then extract the features from that, particularly the nodes and which canes there are. And the base, which is called the head of the vine, that bit there. The geometry is all defined in terms of those things. And the guys at Waikato developed this pruning tool. It's easy to cut the vines. The trick is not to cut the wires and not to damage the wires, because if you damage the wires, eventually they break. So this tool is designed to let the wire slide out of the way when the cutting tool cuts the vine or the cane. So at the moment it's kind of working, but to get to the end of this project, and there's a couple more seasons to go, we need to do like hundreds, thousands, ideally, of operations to make sure that it's effective. And the companies that want to use this kind of stuff want to see an evaluation that shows that it's going to work in a commercial environment. So that's why it needs to have quite a lot of evaluation, which is what we want to do. And there's nothing bad about that, because when you publish your work, you need to have good evaluation anyway. So it'll help us publish it as well. I think we already saw all that. And so for the thinning apples, when the guys at Waikato made a larger Archie, this is called Archie Senior, and it's high enough, 3 or 4 meters, to go over an apple tree row. And typically apples are grown in a 2D structure, and it turns out to be the best way to grow apples anyway, is to grow them on a sort of a flat plane and a certain spacing between the apples and the rows, which works for automation, and in particular this kind of automation. And that gives you better productivity for apples as well, because you get more light, which is the key point. So the plant people have studied this, and there was a big project on this in New Zealand in the Hawke's Bay. And so we're using the same structure for that. And apples in Washington State, a lot of growers are doing the same thing. So that's probably the biggest apple producing region in the world, I think, Washington State. So there's a lot of links between New Zealand and Washington State growers. So we've visited, and they're also growing stuff on 2D structures. Sometimes it's a single 2D structure, sometimes it's sort of a V shape, which is pretty similar. But both of those things are good for automation, because it's flat and you don't need to reach into the bush, and you have less to worry about occlusion. So that's probably enough of that. I'm going to run out of time. So I'm going to talk a little bit about the national scene in New Zealand. So there are probably 2 initiatives to talk about. One is a government project called Science for Technological Innovation, which is something I'm a deputy director and the theme leader for sensors, robotics and automation, which is a theme in that program. So this was a program for advancing New Zealand's capacity to use physical sciences and engineering for economic growth. So tech for economic growth. And so this project was $100 million over about 10 years. So we've been funding, other funding projects to advance that and improve the capability in the country, I guess. One of those projects was run by Armin Werner from Lincoln Agritech, and he's running this project called about adaptable robots. And that's making robots work better, mainly outdoors, but also in factories. And that's also got 6 research organizations and industry advisory group. And the focus is kind of outdoors, which is in their case, it's about forestry. So making a robot in forestry, and I'll show you a little slide on that shortly. The other initiative is NZRAS, which is New Zealand Robotics Automation and Sensing, which is just a network organisation we put together about 5 years ago with mainly a bunch of researchers, most of the robotics people in the country. So the Waikato guys, Mike, Duke and Lim do a lot of agritech work. At Canterbury, Richard Green and his colleagues had already worked on grapevine pruning in the past, and now working on and they work on our Maritech project, now working with drones. Rich has done a lot of work with drones. Currently his project is about drones with tools. So climbing, flying up into trees, taking samples from the tops of trees, for example, is one, but other operations on infrastructure are another example. And then Johan Potgieter at Massey made a substation monitoring robot, which then has also ended up in the SIFTI project for forestry. Victoria's got a focus on AI. Will Brown was there doing that and working on with us in this group. He's gone to QUT and he still works with us on NZRAS. And Lincoln Agritech is a sort of a private research company owned by Lincoln University in the South Island. And they do a lot of field automation work with Ian Woodhead and Armin Werner. And at Auckland, we kind of focus on robotics, a lot on software, and in particular on vision and the machine learning part. So we meet together and work on this on a regular basis. As an example, this is some of Hin's other work at Waikato. It's an asparagus harvester, which is doing pretty well, and they've taken it across to California and shown it and got a lot of interest. So also working with Robotics Plus, so that's turning into a product. And this is the forestry robot I was talking about, which is pretty much similar to the substation monitoring robot. And that's evolved now into a project for mulching and forestry tracks, so kind of keeping tracks open in forest. And the Lincoln Agritech guys are also working on the pruning work with us in the Maritech project. In terms of the robotics industry, Robotics Plus, as you heard about yesterday, is a kind of in New Zealand is a key player in New Zealand robotics. Also, there are a couple of companies that do meat processing. One of them, Scott Automation in the South Island. Another one is Miller's Mechanical, which is derived from the original refrigeration technology that was used at the turn of last century, not the turn of this century, the turn of last century, sending refrigerated sheep meat to the Northern Hemisphere. I think the first ship was refrigeration ship was in like 1898 or something. So it's been a big thing for New Zealand all that time, and that has moved on to meat processing automation to improve the productivity in the industry. Am I run out of time, have I? Minas is approaching, or maybe he's just getting close. In Christchurch, there's a nice company called Design Energy who will design a robotics installation for your factory, and they've installed some hundreds of robots around the country doing small operations for assembly, for example. Cando's an integrator, which came out of an organisation called Callaghan Innovation, which is a government innovation initiative, if you like. And Rockos is an example of a startup company that started by a couple of young graduates in Auckland. They made a dashboard for controlling swarms of robots, and they were recently acquired by Drone Deploy. And so they're carrying on. It's sort of a typical story in New Zealand. You make a startup, make it good, and then sell it to somebody who's got a lot of money overseas. So there's been a lot of that sort of thing happening. Hopefully it'll keep going. And then there's a bunch of other companies. There's people doing automating, retrofitting existing orchard machinery. There's a company called Invert Robotics that does tank inspection and also inspects and I think paints aeroplanes. Their technology is a climbing robot, so it climbs up inside huge stainless steel milk tanks and inspects the tank for damage, which is something that has to be done. There's a underwater drone video company down the road called Boxfish, who we've done some work with as well. Callaghan Innovation, the government group, has a robotics group run by Patrick Lim, and they've been involved in a lot of, they do mainly R&D, and they've been involved a lot with for example, with Miller's Mechanical on the development of meat processing robots. There's an exoskeleton company in Auckland. Crown, you might have met some of the Crown people who are here, and they've been presenting some papers. They were at ACRA anyway, presenting papers last week. Crown's Research and Development Centre is here in Auckland. They bought a company that was a startup here called Inro, which came out of our lab originally. So the guys from Inro were originally in our lab doing the outdoor robot stuff, and then turned into a company, and then Crown bought it to make their research centre, which is here. And there's a fruit handling company. There's a bunch of integrators, and Motion Design is a kind of design company that designs automation, has worked also in the meat processing area. AB&B's got an office here. And then there's a couple of drone companies that do stuff, for example, going to the Pacific Islands when there's a disaster to capture data about what's happening. And then so we created a roadmap, because the thing that's missing in New Zealand is bringing the whole ecosystem together. It's like a lot of places, you know, we don't talk to each other enough, we don't talk to industry enough. So bringing that together and getting the government to front up to make it happen a bit better. So there are quite a few opportunities, mainly about automation. New Zealand's quite low on the productivity ranking because we work too many hours and don't make enough money. So we need to improve on that. And improving on labour issues. Automation in the primary sector is a big thing. There's a government program to improve that, because the primary sector is the largest export for New Zealand, and it's on the farm and processing after the farm. Also, fibre is important. Wool and carpet are really important, and growing. There's a few companies, but they don't use enough wool. So if you'd like to use wool for something, please go ahead. And there's opportunities with climate problems, which are happening everywhere around the world. In New Zealand, the Maori economy is growing faster than the rest of the economy. So there's a lot of opportunities for automation and improvement of productivity there. And health and safety is important in forestry. That's why those guys are working in forestry, because it's probably the most dangerous industry in the country. Healthcare and social support. I think there's a big piece about mental health, for example, where robots could help more. New Zealand's got a good research and development capability, at least we think so. And so bringing that all together a bit and improving our commercialization, those are the opportunities. There's a lot of challenges, though. The regulation is always going to be an issue for some of the robotics work. And so we need to work on that, and we need the government to help with it. We just can't get enough Maori and Pacific Island researchers. There's just not enough people getting trained. So the pipeline, the STEM pipeline into doing robotics is something that we are trying to improve. And the rest of it's about focusing the research and development and better investment into it. And currently it's a problem because the government is currently still reviewing the funding structure across the whole country for science and technology. Hopefully they'll get around to finishing that job and we'll have a bit more clarity. Anyway, that's what I wanted to tell you about the New Zealand scene.
We have enough time for 1-2 questions. Yes, please, Daniel.
Oh, so thank you for your talk, and I wanted to ask something about the caregiving robot that you were talking about near the beginning. You mentioned using them for like indigenous sign language and showing, you know, empathy and so on. So for the sign language part, I'm wondering, what is the problem that the robot is trying to do? Is it just recognizing like a video, or is it doing the communication? And how do you handle the technical challenges like the fluidity and learning from video and using both the facial recognition and hand recognition? Like how did that problem work?
Yeah, one of the key technical points about that project is understanding the emotional nuance that the signer is expressing, because signers use their face a lot, for example. So understanding the facial expression is one of the key parts of the project. So we've already done some work on that, so doing some more on that, and then connecting that with what people are signing. And a lot of the work at the moment actually is engaging with different Maori groups, because Maori Sign Language is different from New Zealand Sign Language, which is different from, for example, American Sign Language. So Maori have specific words and signs that they want to use, and not all of these are even created at the moment. Yeah, it's the situation's in a kind of a bad state at the moment. For example, there's a Maori word hangi, which is a feast where you cook your food in a hole in the ground on hot stones and cover it with earth and leave it for a few hours. It's called a hangi, and so I think in Hawaii it's called something that's similar in other Pacific Islands, but with a different name. So the sign language for that word traditionally is a sign of somebody hanging by the neck, because the English word hang sounds like the Maori word hangi, and it's spelt similarly. So this, of course, is completely ridiculous for Maori people having that as the sign. So that sign has to be changed. And so there's a few other examples. So we're doing a lot of work engaging and visiting and talking with Maori groups, including Maori deaf people, to understand what it is that is really the requirement. But the key technical thing then will be understanding the emotions that the sign is expressing. Yeah. That sort of half answers your question, I think.
Okay, thank you. We have enough time for one more question. Yes.
Thank you a lot for the talk. Obviously, the landscape of robotics in New Zealand is vast and interesting and diverse. How you would weight role of government versus private investment in developing and moving forward?
That's a really good question. The data tells us that in terms of there's a kind of a ranking of countries of how much they invest, what percentage of GDP is invested in research and development in the country. New Zealand is ranked sort of in the middle, so middle to low. It's not enough, and our government is trying to increase that. In the last 5 years, the government investment in R&D has increased a bit. So in some way, like maybe 0.5% or something, which is quite a bit. And that's probably good, but the industry investment in research and development is probably not as high as it should be. It should be higher. And I don't think people understand it entirely well, but that's something, we're trying to help improve by creating technology. Most of our large projects are funded by government, mainly by that department called MB, which is Business Innovation and whatever it is. Employment, yeah, they kind of run everything, sometimes called the Uber department. But so to get them to fund something, you need a good science project, and you also need a sort of business plan information of how your technology will get into the market. And you need partners. If your company will co-fund the work, that adds strength to it. But mainly funded by government, yeah. The difference in New Zealand is we don't have the big companies that other countries have. We don't have, Amazon and Google and all the big companies that you would find in the US. And we also don't have the big chaebols that you would find in South Korea, for example. I think our biggest company is probably Fisher & Paykel Healthcare, which is $900 million a year is what they do, which is sort of too small to.
Okay, thanks so much.